In this video, we're going to talk about continuous random variables. So what we've been doing so far have been discrete random variables because everything was just done with us in terms of a table. So everything was discrete. Okay, we basically had particular numbers with probabilities. Now we're going to deal a lot with continuous random variables. And usually what happens is that with continuous random variables, you have some sort of function, so some sort of curve. And the whole point of this is that you want to be able to find between two values, okay, you want to find the area. So now the probability is actually the area under this curve. So probability is basically the area under the curve. Okay, so if you've taken calculus, this will actually be the integral of this particular function, but we're not going to be doing integration in this class. So also to note, the probability of x equaling a particular number is equal to 0. Because what happens is that you have an infinite amount of numbers here, infinite amount of possibilities that you can get. The possibility that you get one particular number is one out of this millions and millions of numbers that you have there. So that is almost impossible. Okay, so you have an infinite number of possibilities. So usually these guys, we call them probability density curves. Just fancy way, probability density curves. So that's what we have them. They have great properties. So let me go ahead and show you what the properties of these guys are. So the properties here is that the probability of x is always going to be between 0 and 1, which makes sense. Probability should only be between 0 and 1. The probability, which in this case is our area, okay? This one, if you were to add all of this area, it's always going to be equal to 1. Okay. Also, the probability of x equaling a, some particular number, is approximately equal to 0. Also, a couple things. The probability of x being less than a is equal to the probability of x being less than or equal to a. And same thing with it goes with the probability of x being greater than or equal to a. That's also, oh, maybe I should write greater than. Oops. This is also equal to the probability of x being greater than or equal to a. Okay. Now, why is this? Why? Because this was not the case when we had discrete random variables. You actually had to include the a. Now, why is it that it doesn't matter if I include it or not? Well, think about it this way. If you had the probability of x being less than or equal to a, well, I can always break this up as the probability of x being less than a plus the probability of x equaling a. Okay, so basically I just put the equals and I split them up. Now notice that this thing is equal to 0, so this goes away. So the probability of x being less than or equal to a will be the same as the probability of x being less than a. Okay, just a little FYI. Okay, so let's do a couple problems. This is really what I want you to know for these types of problems. And because we're not going to be doing integration here, because most of you guys have not taken calculus, what we're going to do instead, we're going to do a little bit of geometry, okay? And some of the geometry problems that you're going to be looking at is looking at areas of triangles and of how do you call them, and rectangles. So maybe not example. Well, let's just leave it like that. So let's say you have a triangle. Okay, so here's our triangle. And it has this bottom part, we're going to call it the base, and here is the height. So if you ever want to find the area of a triangle, it's going to be 1/2 base times height. Okay, so that's for the first one. Then let's say you have some sort of box or a square or this rectangle, 90 degrees all over the place. Here is the length, here is the width. So the area is going to be equal to length times width. Okay, so this is for a triangle. Okay, this is for a rectangle. Okay, now sometimes you'll find that you're gonna find trapezoids. Okay, trapezoids are kind of look like this. Usually I will give you the formula, but I think it's best whenever you have a trapezoid to kind of divide it up into, because you notice that you can kind of divide this into two triangles and then one little box in the middle. But there is a formula. The formula is just 1/2 times the height, a plus b. So basically this height right here is your h, okay? This from here to here is going to be your a, and from here to here is going to be your b. So you can find the area of this trapezoid using this particular formula. Now, you don't need to use this formula if you don't want to, but because you can always break it up into two triangles and a rectangle, and it'll still give you the same answer. So let's just do an example. Okay, so what you want to find is given the PDF. Okay, so here is our probability density function. Okay, so I have this funky looking trapezoid right here. Okay, and you have 0, right here is going to be 2, right here is going to be 4, and right here is going to be 6. Okay, and the height of this thing is going to be 0.25. Okay, and what we want to figure out, the first thing is show that this is a PDF. Okay, so that's what we want to show. Okay, so the first thing that we really want to be able to do is try to figure out that the PDF of this is just going to be the area bound under this particular curve. So we need to figure out what all of this area is. So one thing that you can do is you can just break this up into two different shapes. Okay, so let's first do it using the regular a triangle. So we have this triangle, we have this box, and then we have another triangle. So basically we need to add the areas of each of them. So if you look at the area of this triangle right here, this area is just going to be 1/2 base. So the base here, if you see the length here is going to be 2 times the height. The height here is going to be this side. Notice that this height is all of this part, which is 0.25. Plus the length times the width of this box. So here's this box. So this box has a width of 0.25. And then the length, which is how far this is. Well, how far is 2 from 4? That's just 2. So it's going to be 2. Plus, now we're going to look at this other triangle over here. Okay. This is going to be 1/2. Base, in this case, is going to be how far 4 from 6 is, which is going to be 2. And then the height, which in this case is going to be 0.25. You put this all together and you're going to get 1. Okay. All right, you could have also used the formula for the trapezoid. You could have said that 1/2 height a plus b. So you're going to have 1/2. The height in this case of this thing is going to be 0.25. And then times a plus b. A in this case is going to be this top layer, this guy. And this guy is just going to be how far 2 is from 4, which is just 2, plus this bottom layer, which in this case is how far 0 is from 6, that's just 6. Okay, and if you go ahead and put that in your calculator, you also get 1. Okay, so either way, whether you want to break it up into 3 different shapes or you see formula for the trapezoid, they both should work. Okay, now let's do part B. Okay, so part B says find the probability that x is less than 2 or equal to 2. Okay, so the probability that x is less than or equal to 2. Okay, so what would that be? X is less than or equal to 2. Well, everything that's less than or equal to 2 is all of this area. So here is 2. Everything less than that is all of this guy. So we basically are finding the area of this particular triangle. So that's going to be 1/2. The base in this case is going to be 2. The height of this triangle is going to be 0.25. And what we're going to get is 0.25. So that is going to be the probability of that thing. Okay, and now what we want to figure out is this guy. Okay, so part C. So find the probability that x is between 2 and 3. Okay, all right, so now between 2 and 3. So 3 is going to be somewhere in the middle. So here is 3. Okay, so somewhere in the middle. And everything that's between 2 and 3, which in this case is going to be all of this guy. Okay, all of this is going to be the area between 2 and 3, which is basically this box. Okay, so we're going to find this area. So the probability of between 2, where x being between 2 and 3 is going to be length times width. So the length in this case is going to be the difference between 2 and 3, how far that is, which is just 1. And the width is going to be this thing, which is going to be this 0.25, which in this case is going to be still 0.25. Okay, now don't be custom that it's going to be the same answer. You could have also gotten something completely different. So they're not always going to be the same. Sometimes there might be something a little bit more. Okay, so that's basically it for these types of problems. Just make sure that you know how to do the geometry behind it and be able to solve some probability problems.